Hey everybody, John here. Today we're going to talk about solving trigonometric equations. So we're not going to cover absolutely everything on here. I'm going to skip a couple of examples. I just want to get the main idea behind solving, and mostly behind finding all the solutions of an equation. So here we're supposed to find all the solutions of sine of x equals root 2 over 2, cosine of theta equals negative root 3 over 2, and tan of x equals negative root 3. So let's start with sine of x equals root 2 over 2. Now if we think about our unit circle, we know that sine is equal to root 2 over 2 here at pi over 4. And sine is also equal to positive root 2 over 2 over here in the second quadrant. And that's at 3 pi over 4. And so if I plugged pi over 4 in for x, I'd get root 2 over 2. If I plugged 3 pi over 4 in for x, I'd also get root 2 over 2. So we know that if x equals pi over 4, I'm going to get my answer. We also know that if x equals 3 pi over 4, I'm going to get that positive root 2 over 2. But now what we have to consider is that's not all of the solutions, because if I went all the way around this circle and came back to pi over 4, that would also give me a solution. So 9 pi over 4 would work. And if I went all the way around this circle and came to here, that would also be a solution. Okay? And so what we're going to do is we're going to add 2n pi to this, where n is an integer. And the reason this is going to work is an integer is any whole number value, positive or negative. And so, like if I plug negative 1 into that, I could also go backwards here to get to that value. And so negative 7 pi over 4 would work. So every time I can plug any integer into here. So integers, so n is going to be some sort of integer. So negative negative 3, negative 2, negative 1, 0, 1, 2, and so on and so forth. These are the numbers that I could plug into here. And that covers every solution for this angle here, this one, in the first quadrant. So I'm going to do the same thing for all of the angles that are in the second quadrant. And so I can say where n is an integer, and I can write it out, or I can use this mathematical symbol here. So this is an epsilon, which means contained within, and then this is the symbol for the set of integers. It's a bold Z. So I'll take either one. And these are all the solutions to this equation right here. So let's do this again for cosine. Cosine again has a period of 2 pi, so that's where this 2 pi comes from in this this addition part of my solution. But where does cosine equal negative root 3 over 2? Well, thinking about our unit circle again, let me draw a new one. Ooh, that was bad. So cosine is negative in the second and the third quadrant. And so root 3 over 2 is the biggest of the numbers. So it's going to be this angle here, and then this angle here. Oh, sorry. I'm thinking y. It's going to be this angle here. I'm further to the left, and this angle here. So it's going to be pi over 6 short of pi. So pi over 6 short of pi is going to be 5 pi over 6. So x equals 5 pi over 6. Oh, not x. Theta equals 5 pi over 6. And then there's also theta is going to be pi over 6 past pi, which is 7 pi over 6. Now that gives me my first two answers, and then I can go around this unit circle as many times as I want, and as long as I land pi over 6 short of pi and pi over 6 past pi, I'm going to get another solution. So plus 2n pi plus 2n pi, and please always write where n is an integer, however you want to write it. So this is an n. So those are my solutions. Those are all of the solutions for cosine theta. It's all infinitely many of them. So now let's figure out where tan of x is equal to negative root 3. So if we think about tan being a sine over cosine, or the y over the x, we want a root 3 over 2 over a 1/2. So that's when sine is root 3 over 2, and cosine is 1/2. So on this unit circle, we want it to be one of these taller angles. So that's going to be here, right? But we want it to be negative, so it's actually going to be in the second quadrant here. And so this is pi over 3. And so this is 2 pi over 3 here. And so x is going to equal 2 pi over 3. This is the first time that this happens. It also happens here in the third quadrant. It happens right here, which is pi away, right? But pi is the period for tangent, and so I don't need to think of this as a separate angle. So 5 pi over 3 also works, but if I just add n pi to this, which is pi is the period for tangent, this covers 5 pi over 3, and then it covers the next time around, and then the next time around, and so on and so forth. So I'm just adding a pi every time. I'm adding a period, and this covers all of the solutions, of course, where n is an integer. So those are all of the solutions. So algebraically, we're writing the infinitely many solutions to each of these problems. Now, the ones we did last time, they just asked you to solve find all the solutions between 0 and 2 pi, and so there were a finite number of solutions. This one says find all solutions, and so that's how you know the difference. And we're going to do some more problems where we're just finding the solutions between 0 and 2 pi, and that's fine. And that's what we're going to do for the rest of the time. We're actually not going to tackle this. There's one more example where, no, it looks like all of them are just find the solution between 0 and 2 pi. All right. So I'll see you in the next video.